Hi, thanks for joining us. I'm Stephen Yules, Vice President and General Manager for Red Hat's AI Business Unit, and I'm joined today by Mike Gualtieri from Forrester, and he is their Vice President and Principal Analyst. Today, we're going to talk about some of the AI perspectives and trends we're seeing in the market. Thanks for joining me today, Mike.
Good to be here.
All right, so just to set the stage here a little bit, I want to talk a little bit about the evolution of generative AI and what we've seen, because certainly like predictive AI has been around for decades. Lots of customers have used it, but generative AI has come strong on the scene here in the last 18 months. And we've really seen an evolution over those 18 months. You know, back when ChatGPT first arrived, everyone was asking interesting questions, and it really opened the imagination of the industry to the art of the possible. A lot of customers that we talked to spent the next to 9 to 12 months trying to figure out, of all the great ideas, which of those ideas would make viable business solutions. So they went into and started executing a lot of proof of concepts and pilots, trying to narrow down the volume of use cases to those that could drive business value, actually needed generative AI to solve that problem, and was a cost effective solution. And now, in probably the last 6 months or so, we've really seen customers moving out of that proof of concept and pilot stage into productionalizing those use cases. So they found areas where they think they can drive value, and they're really trying to put them into production and able to operationalize them across the organization. How does this line up with maybe your experience here, Mike?
Well, it's fast. Like just with Gen AI coming on the stage, the types of inquiries I was getting from companies like, sort of like, is this dangerous, right? All the journalistic articles about dangerous technology and stuff. So it's kind of gone from there to we're putting stuff in production. How do we put it in production? I mean, this is a very, very short period of time. I think there's a couple of reasons for that. Number one, just the accessibility that people had to this technology, right? Using ChatGPT, they kind of got a sense of, well, okay, what is this good for? What isn't it good for? And so understanding it, I think, made it more real. And when something's more real, they can start applying, more use cases in the enterprise. I think the other thing that helped here is RAG, retrieval augmented generation, which is kind of the number one use case that I've heard enterprises doing because it allows them to combine their own data, with some of these amazing models out there. And the other thing is that these models are pre-trained, right? So before with as you said with predictive AI, that went very slow, and predictive AI is still fabulous, right? It's very complementary to generative AI, but it's very different. You're building a model yourself, and for that you need teams of data scientists. With Gen AI, right? These models are pre-built by companies like OpenAI, IBM, AWS, Cohere, etc. So yeah, it's been remarkable, but I still think it's only the beginning. And now what's happening is a lot of enterprises are saying, well, now that we move these into production, there's a lot of challenges, both from a software standpoint and both from an infrastructure standpoint.
No, I agree, and I like the accessibility one. Like one of the biggest things we're seeing, like I grew up in the AI world ever since I graduated college, and on the predictive side, I love the way you framed it. We saw a lot of that specialization in specific parts of the business that had deep skill sets to be able to build, maintain, and deploy those systems. But with generative AI, there is this expectation that it's accessible to an entire enterprise. And that changes the game a little bit on who gets engaged, what guardrails need to exist for that engagement, and what does production look like? Because you can't be guaranteed anymore that is this highly specialized set of skills that are moving those things into production and understand AI. And that's a great segue here on to the next one. It's not, while it certainly has lowered the bar for integration, there's still a lot of challenges that come with generative AI. When we've talked with customers, we've noticed that as they've tried to move from proof of concept and into production, the POC, it provided enough value to move to the next stage. But when they rolled into production, they were hit with a couple of unexpected outcomes. One, like the models, like a lot of the general services weren't providing a lot of the specificity they needed for their business, which I think ties into what you were saying on customers have this desire to integrate their data into these models, whether it's RAG or fine tuning. Like that is a hard reality. There was also a lot of concerns on security, right? Like when you're sending this data in, who's getting access to it? How's it being used? There were overall cost concerns, right? There's a lot of unpredictability when you think maybe you're going to have 10 users using a particular service. It turns out you end up with 1,000, and your cost per token goes up, right? There's a lot of variability in cost. And then overall agility, like how easy it was to switch between models, how easy it was to try out different things. Companies didn't realize these until they were on that precipice for adoption. Good news was, like, the other trend at the time when a lot of this was happening, we started to see this increase in more permissibly licensed models, right? The things that were coming out like Llama and Mistral, and now what Red Hat has done here with Granite, which give customers more control over the data itself, because now they can run it in their own private data center, as well as cost, because they can use their own hardware versus having to pay for a service on a per user or per token basis. So this has helped them, when it comes to infusing data into their generative AI, and help them kind of control their overall resource utilization and optimization. But there's still new concerns now that have come out of that, right? Like now, I love what you said earlier here on it's lowered the bar for integration, but it's presented new challenges, right? Like which models to use, which are secure, how do I switch between models quickly, which techniques apply for certain use cases, and then managing those models at scale. We see a lot of customers who do a great job getting that first model up there, but then when it comes time to roll out a second, a third, a 10th, 50th, it's really hard to keep all of the different platforms optimized, make sure your resources are utilized, monitor which data is going in, like how do you monitor when they're in production. So that whole scale and efficiency has become a real theme around generative AI. Again, like I want to throw it to you here. Like you certainly talk with like the breadth of folks across not just on-prem but cloud service. So what's your thoughts?
Yeah, I mean, one of the ways I look at generative AI is from the AI infrastructure side of things too. And when I think about that, I think of three primary workloads: a data prep workload, right, preparing the data, training, and inferencing. Now, in generative AI, no one really thought that they would do anything other than inferencing, because when ChatGPT came out, everyone said, "Oh, ChatGPT, OpenAI spent hundreds of millions of dollars training this model, and there's no one that could possibly do that, or very few companies." Actually, now what we've seen is that there's thousands of models, and that almost every tech company, you mentioned Granite, there's the hyperscalers, there's startups, and then there's Hugging Face, which is an open source community of thousands of models and variations on models. And so now what we're seeing is companies are thinking, well, yeah, I do want to use a pre-trained model because there's some use cases for it. But you mentioned fine tuning. And it's like, but I may want to fine tune the model. And now we're seeing infrastructure plays and services out there where it's like, well, maybe I actually can, for some use cases, want to build my model. Now, my explanation for this is that when you've got AI researchers focusing on training the model, they're really focused on the model architecture, right? But once this came to the fore, computer scientists, more general computer scientists, looked at this, and now they've been optimizing the heck out of this. They've been looking at, they may have no AI expertise, but when they understand the architecture, they say, oh, well, we can optimize this, that, and the other thing. I'm not saying that these models still aren't big and they're still not hard, but there's this vast diversity of sizes of models and use cases for models. So that, in addition to the model choice that you talked about, now there's more options for an enterprise in terms of not just using a model, but perhaps fine-tuning a model and maybe even training a model. And the reality is they'll probably do all of these things if you're an enterprise of a certain size.
Oh, I agree. I mean, I go back to the days when, like, again, going back to predictive AI, if you kind of view this as following a similar trend, right? You didn't have one massive financial model that served your fraud and risk analysis and revenue predictions, right? You had very specific models, targeted specific use cases. They were much smaller. Like, I see a lot of the same trends happening with generative AI, right? Like, while it's great to be able to solve the internet-wide set of problems that like a Chat GPT and a Llama 3 can solve, enterprises really need to focus on very specific problems that don't necessarily require that size of a model. So it's really interesting to be a part of and watch again.
Yeah, and even the the we think of these as human language models, right? But there's the code models, right? There's Project Wisdom. There's all of the code assist model, other code assist models out there. But and I think people, generally they're aware of that, right? It's human language in this code. But what they may not be aware of is that every engineering discipline has its own language. It has its own artifacts. And now we see companies starting to train models based upon, how do I specify automotive parts? How do I specify new molecules for drug discovery or material science? So, I mean, we're just getting started.
No, it is. It has been exciting. And actually, let's drill in on some of those. You had mentioned some of like the AI infrastructure and a lot of the key elements of that. So let's talk a little bit about what some of those core challenges are. The way we tend to frame it up is around like workload management being the big one, right? So challenges you're going to encounter when you're trading, serving, monitoring, being able to have these jobs, whether they're tuning jobs or raw training jobs, specify and take advantage of specific hardware accelerators, right? You don't want non GPU jobs running on GPUs and vice versa. You want these things to be able to scale, so that it can meet demand. And then there's orchestration. Like, rarely is it just one set of code that actually does the full training and data ingestion and data quality and check and then produce the model. So being able to orchestrate across multiple disciplines. So tying data engineer data pipelines, then passing that data into AI pipelines for model development, which then connect to like DevOps pipelines for being able to be integrated into agents and applications. Third, like we see a lot on the platform and vendor complexity side of things, right? There's a lot of very specific hardware platforms that are highly tuned to specific model use cases that take advantage of specific accelerators. And so being able to like orchestrate jobs into those particular platforms. Also, there's also, like you mentioned it, there's a new model coming out every week. There's a new technology coming out every week. So being able to adopt those emerging technologies while maintaining still a consistent operational platform for productionalizing models becomes a concern. And then you start talking about fleet management, right? Like, again, we're working toward a world where I loved like what you said there on all the different engineering disciplines have their own model. That's dozens and dozens of models within a single organization. So
Yeah.
being able to monitor which models are deployed where, how are they performing, what was the lineage, what data got used in them, like, all of that starts to become the real problem at scale. And I'd love for you to talk a little bit more about in these areas, like what are you seeing and like, which of these are further along than others, right? This is still a real heavily emerging space. So, which ones do you see some advancements being made versus others still on the heavy emerging side?
So I think where most of the focus uh, has been on workload management from a optimization standpoint. So, or and more specifically, utilization. So I'm not using too much infrastructure. I'm not using too little that the job takes longer. So there's been a lot of that type of infrastructure optimization going on. There's been a lot of focus on the cost. I think that's warranted, but the cost equation also comes with the value, the value of that model as well. So you don't just want to reduce the cost, you want to optimize how long it takes, for example, the latency of an inference. If you're sometimes it can be very jittery if you ask ChatGPT a question, put some text. I mean, if you're doing some customer experience e-commerce application, you want latency like that,
Mm-hmm.
right? So there's different, and if you're training, you want high throughput because you don't want to wait a long time for the model. So I think that's where a lot of this, there's a lot of focus on there, and I think it's warranted. I think other considerations, though, in the challenging, because look, you mentioned two things that are absolutely true. Innovation is occurring like crazy, not just with the companies everyone knows about, but new companies and new models and open source, open weights coming out. But there's also the data, right? So now you have to start thinking of real time. You have to, if you're an enterprise, right? It's like, oh, can I have a model that's operating on data that's 6 months old or 3 months old? maybe I can, but guess what? There's use cases where it can't be a day old. So now you've got training workloads that or fine tuning workloads, or even RAG vector database workloads that you have to do on a regular basis. These become ongoing workloads. Not only that, if you start changing and swapping in different models, well, now you have to test those, right? It's not enough to monitor and see the results. Well, when you get something new, now you have to test it. So now you need a whole testing regime, and you need infrastructure for that as well. So those are two other things that I think are becoming more important.
No, I think you nailed it. Like, what are you seeing from like a customer interest perspective on like when they're looking at a platform? Do you think they have moved beyond just the excitement of the model themselves, and that enterprise are really starting to focus on this larger scale problem where models are a subcomponent in a much larger system? Have we kind of reached that point?
Well, that's what I love about this, right? Because now IT ops is getting involved because they have a huge role to play. Now software development is getting involved because they have to be able to integrate this into the software. I mean, you remember like with predictive AI, everyone said, oh, ML ops, it takes 6 months to do a model. A lot of that's true, but there's a lot of reasons for that. But in the Gen AI space, less so because the models are pre-trained. There's a lot more value there that's ready to go. And when it's ready to go, it means we need to integrate this fast into our software processes, make sure that we have the infrastructure that can scale to it. And that's where software people and IT ops that's their regular role. Yeah. And so I haven't seen them get more involved as they are now in Gen AI.
No, that's great. That's great. And so that brings us then to kind of that model lifecycle set of challenges, right? It's like, what does it take now to get models into production? So you've got them trained, right? You're happy with the results. A lot of what we see is that rollout coordination that you mentioned, right? It's the data engineers to the AI engineers to the software developers to the IT ops who have to monitor this stuff. Like making that pipeline quick. 6 months is going to be too short, right? Like the average lifespan of these models is like 4 days. So like 6 months, you're not going to make it in time. Then you start talking about software supply chain, right? Like everyone probably still remembers the Log4j stuff and how that kind of opened everyone's eyes to these potential vulnerabilities. And that wasn't even a malicious one, right? So like being able to track what software and components are going into these models, have that auditability, traceability, transparency, understanding that starts to become a concern. All of that drives agility, right? And you mentioned it. The ability to iterate on these models, whether it's the same model with new data or trying out new models under the covers with the same data for performance gains or efficiency gains, having the agility to be able to play across these domains is really going to drive a lot of customer value, right? It allows them to do experiments, to roll this out with confidence. And what I always see in customers here is sort of the last point is if you're not able to achieve these, like you may get that first model out, but if you're not able to monitor it, you don't understand how the data is being used, you can't like effectively life cycle it. This leads to a lot of loss of confidence. And in the predictive AI world, back then, like companies could still survive without having taken advantage of AI and the use of their data. But I think at this point, like we always kind of hear, is AI another trend? Is it a hype cycle? I think at this point, there's enough value being generated to say this is not going away. Like we're going to continue to invest and continue to iterate on it. And it may not look the same when we're done as it does today, but it's going to exist. And for companies that lose confidence and aren't able to put AI into production, they're going to be putting their businesses at risk here. So there has to be, in my view, there has to be a heavy emphasis on that infrastructure component. Like, what is that core platform? Yeah, go for it.
Yeah, no, I love your list here, and when I see when I see your software supply chain bullet, which I agree with, I almost want to add a bullet and say infrastructure supply chain as well, because this, it's very enterprise specific with their infrastructure strategy, and it's use case specific where you're going to run these workloads. So I hear from many of our clients, it's like, hyperscalers are extraordinarily expensive when you're running hot, meaning running workloads around the clock, right? So when they have a production workload and they need to run it, sometimes I've got I've got colo, I've got data center, I want to run it here. So I think the point is that enterprises are going to have to be very flexible in where they have the ability to run these workloads. It may be influenced by data gravity, say on the data prep side. Training may have to do with the frequency of training, certainly experimentation, and inferencing. Well, where do those applications exist? So I think they need a lot of infrastructure flexibility as well.
No, that's a great one. Certainly, like we didn't even tee you up for that one. That was great. Like coming from Red Hat, where consistency across hyperscalers and on-prem, whether it's for training or inference, is sort of our
Yeah.
key competency. Like I couldn't agree more, right? And like I think that's definitely an area that a lot of people overlook right now because you can see a lot of innovation happening in certain areas, and you gravitate toward that space. But unless you're looking at it, like you said, in the kind of that holistic view of how are you going to enable AI for the enterprise, some of these things kind of you miss them, right? And this is where I'm hoping the year of 2024 is that infrastructure sort of focus on what's it going to take to operationalize AI.
Yeah.
I'd love to see like the other one we talk a little bit about is like on the governance side. What are you seeing on the requirements around AI governance, and what's driving a lot of the considerations there?
So there's three main things that I hear. I think it's broader than that, but I'll just mention there's three. People are concerned about IP rights, right? So they don't want, if they're using some sort of more of a public commercial model, they don't want their data being used in the training, or they want to know if it will be. But they're also interested in the IP rights of others that went into training the model, right? So that's why I think you mentioned the granite model. I think there's indemnification even.
Yeah,
Isn't there indemnification?
yeah, you're right. Yeah,
Which means, I think that means, I'm not a lawyer, but I think that means that if a company uses granite and gets sued, IBM will indemnify them
correct. Yep, yep.
about those rights. So there's use cases where that's critically important. So they're worried about that. They're worried about hallucinations, of course, and there's ways to mitigate that. Many different, but that's a governance process as well. And they're very concerned with cost, optimizing the cost, because I love to talk about the value side of it too, because if something costs a dollar or even 17 cents, but you're getting $10 of value, I think that's a consideration. But companies have experienced kind of runaway costs, like you mentioned early on in this about, token sizes and stuff. So like if you get like a huge context window, like Google has a million token context windows, and other vendors are opening up those context windows. Wow. That doesn't necessarily eliminate the need for RAG, because you're going to have to be doing that over and over again. So a lot of cost optimization is still important here, even if the value is high.
Yeah.
And that's what IT ops people do, right? They try to optimize that. That's how they get measured.
Yeah.
How, especially against benchmarks against their industry peers.
No, that's a good one. I like the cost one. I think in the early days we saw a lot of the inverse relationship where you could only make $1, but it was costing $10 to run. It was a great idea, but not necessarily the right one to put into production.
Yeah.
Well, I appreciate your time. Anything in closing you want to call folks' attention to? Any predictions for where we're going this year and into 2025?
Well, just that, I think you may have said this in the beginning, that this is not a fad, right? I am hearing companies that are getting real value from this, and I don't think that it's overhyped. I mean, it still is, like, journalistically, as many technologies are, but the enterprises I've talked to, I think, have a real understanding of what they can and cannot do with this. But they also have this sense of the trajectory of how this is going to increasingly get better over time. So I do think we're going to see, a lot of rollouts, going from experimentation to production. And then the other point is that all the ISVs, so the software companies that sell business software, right, they're trying to figure out where Gen AI fits in their products, right? And they're launching features there. So this is going to make it tough for some enterprises because they're going to have to think about, do I implement this use case? Is this a differentiated use case? Or is my accounting software vendor going to add this feature?
Yeah.
Either way, they're going to need the appropriate infrastructure to run on it. So I think everything we talked about is relevant in both cases.
I love that. Like the composability of these systems are going to be essential. Like there's the days of a single vendor providing the full end-to-end stack and set of capabilities are gone, right? So enterprise
Yeah.
focusing on infrastructure, composability, consistency, like that's I totally agree. That's going to be key. So I'm looking forward to us doing this again in 2025, Mike. So
Yeah.
well, I want to thank Mike for joining us from Forrester today. And now I'm going to transition to our next speaker. Martin Isaacson now is going to talk about how to simplify AI adoption using open source and Red Hat and build on what we've talked about here. Thanks, Mike.
Thank you.
Thank you, Stephen. My name is Martin Isaacson, and I'm part of the AI business unit here at Red Hat. I've been working with AI and specifically deep learning for about a decade. I started with AI research. As an example, I did a research collaboration project with Stanford. And then I started building my own and running my own AI startup out of Silicon Valley for the last 5 years. And then me and my team joined Red Hat about 1.5 years ago. So I've really been part of this long journey where we try to convince organizations to buy into AI and start investing into AI. And it's been a long uphill battle. But that's why it's really exciting for me now when I'm here at Red Hat to see that it's actually breaking through. So there are a few reasons why we're seeing this breakthrough in AI. And most importantly, I think it's from the technological breakthroughs we've seen over the last few years. So it's really thanks to the open science and open source movement that we're seeing this breakthrough. And because of this, organizations like OpenAI has been able to capitalize on this open science and open source movement, and they released ChatGPT. And this was the first time that consumers could really interact with a powerful chatbot, in other words, AI. So this in its own way democratized AI and has been a big contribution to the breakthrough we're seeing today. So the technology has become really accessible. So any developer these days can go online and download a sort of state-of-the-art model and build a generative AI application. So they can quickly throw together an MVP and show it to his or her manager, and they can decide if they want to keep investing into this project. So because it's become so accessible, it becomes affordable, and organizations can finally realize value quicker from AI. And it's 2024, so I also argue that many organizations are better prepared from an infrastructure perspective to deal with the ever-increasing data around AI. So today I will tell you about how you can simplify your AI adoption with open source and Red Hat. But first, I want to sort of like set the stage and talk about some challenges we see with AI. And that is most AI projects never reach production. As a matter of fact, almost 90% of the projects never reach production. And for half of the organizations, it takes 7 to 12 months to productize a model. And for a quarter of the organizations, it takes almost more than a year. So these are way too long, and these are really bad numbers. But there are, of course, reasons to these issues. One of the reasons is that AI development is a process that we need to implement. We can't just throw money at it and expect it to work. It doesn't work like that. Another reason is that there's usually a lack of collaboration. And the collaboration we're referring to here is the same that Stephen talked about earlier. And that is between the AI developer or the data scientist, whatever you want to call them, and the app developer. Because in the end, we're not just building AI models for the sake of building AI models. We want to use them for something. We want to see a return on our investment, and that is through AI-enabled applications. And this is where we usually see a bottleneck. And from my own experience before joining Red Hat, when I had my own startup, we worked with a large enterprise customer in the US, and I worked with an AI team in that organization. And they literally took the trained frozen model file and emailed it to the app developers. And I'm sure that they have moved further today, but I think a lot of teams actually still do these types of things, even though they might not want to admit it. because this was just 3-4 years ago. So the collaboration here is where we can usually see some friction. Another reason to the issues that I mentioned earlier is that organizations tend to just hire data scientists and expect them to solve everything. And again, it doesn't work like that. Data scientists are, well, just that, scientists. They're supposed to work with the AI, work with the data, understand the data, and then build models from the data. And this is usually what we call the experimentation phase. And if we then try to operationalize or productize this experimentation phase right away, we will run into a brick wall of technical debt. So operationalizing AI becomes both the solution and a challenge. Just like we need DevOps for app development, we need DevOps for AI. And this is usually called MLOps, or machine learning operations. And just like with any other software development project where we need a clear structure and clear goals of our project, we need that for our AI projects as well. As a matter of fact, when we're adding AI to our project, we're almost more than doubling the complexity of the project. Because now we not only have to consider the app development or DevOps workflow, we also have to consider the MLOps workflow. And there needs to be a collaboration between them. So if we see that we would benefit from adding AI to our project, so be it, then we should do that. But we need to keep in mind that we're adding complexity. However, if we do both AI development and app development on the same platform, we significantly simplify this process. So when we talk about AI, we need to talk about AI workloads. And the most efficient way to run AI workloads is by using containers, or more specifically, a container platform. And Kubernetes is by far the most commonly used container platform. About 50% of the workloads on Kubernetes are AI workloads. But Kubernetes by itself is not enough if you want to use it in the enterprise. You need more things added to it, like multi-cluster management, load balancing, logging, etc. And there are vendors that are productizing open source, like Kubernetes platform, to provide it to the enterprise. So you get enterprise-grade security as well, and these extended capabilities that I just mentioned. And Red Hat is one of those vendors. We offer OpenShift, which is sort of like an enterprise-grade version of Kubernetes. And because it's based on open source, you can easily extend the capabilities of the platform. So if we have a container platform like this, we can have both app development and AI development on the same platform. So we can have the data scientists, the data engineers, the app development, IT ops, all collaborating and working together, which will significantly increase their productivity. Because in the end, it's a team sport. Just like we need to make sure we enable the right tooling, we need to enable and include the right people. And AI needs to be able to run where the data is, which is on the hybrid cloud. So a big thanks to our friends over at IDC who provided these fresh stats of 2024, where we can see that AI workloads are almost evenly distributed across the hybrid cloud. So we need to be able to deploy AI on the cloud, on the edge, on-prem, and even in air-gapped environments. And this is what we see here. So AI needs to be able to run where the data is. And remember, data science, it's not in one specific department. It's spread out throughout the whole organization. So if we can have one common platform for all the different AI workloads, we can avoid issues like shadow IT, which is very common in data science. And we can avoid having multiple tools and platforms, which would just force our employees to learn new things all the time, which has a cost attached to it. So with one common container or hybrid container platform like OpenShift, we can avoid these issues. So for our AI platform, how can we avoid vendor lock-in? How can we make sure that we always have access to the latest innovation? And how can we make sure that we have a flexible enough solution that not only support our current use cases, but our future ones as well? Well, we can do that with a composable hybrid MLOps platform that is based on open source. And that is a lot of buzzwords. So let's go through them one by one so we understand what they actually mean. So with a hybrid MLOps platform, I mean a platform where you can build, train, and tune, serve and deploy, and monitor and manage models on the cloud, on the edge, on-prem, and even in air-gapped environments. And we can do this if we have a tight integration with our hybrid container platform. With composable, I mean that we want a modular platform. Because yes, out of the box, we want our MLOps solution to have the key feature that defines an MLOps platform. But for some verticals and some use cases, we need to be able to extend its capabilities. That's just how it works in AI. So with a modular solution, we can make sure that we easily can extend the capabilities in a plug-and-play manner with other open source components or ecosystem solutions. And being based on open source, we can get this transparency that is desperately needed. We know every single line of code that runs underneath the covers, so we can work with responsible AI. And I also like to see that we get a dynamic product, because the AI software landscape is changing rapidly. We see new innovation almost on a monthly basis. So by productizing open source, we can make sure that we always have our hands on the latest and greatest innovation. So we really want to avoid this fixed one-size-fits-all end-to-end solution, because that would just lock you in. And I'm speaking from personal experience here. The startup that I used to run, we offered such a solution. And again, the AI software landscape is changing too fast. So trying to come up with the features for this end-to-end solution, it's sort of like chasing your own tail. You just won't get there. So that's why we are focusing more on a composable or a modular solution, because in this way you can adopt it piece by piece in your own pace. In other words, build up your own AI capabilities at your own pace. So this will not only simplify your AI adoption, it will also save you money. So you want your AI platform to support both predictive AI or classic AI and generative AI. You want to be able to bring your own models. You want to be able to use open source models like the Llama models or the Mistral models that are hosted on Hugging Face. And you want to be able to go to the ecosystem and use vendor supported models. You want to be able to use foundation models out of the box and serve them in your application. And you also want to be able to build and train your own foundation models even sometimes, perhaps. If you have those if you want to, you should have those capabilities. And for that, you need to have something that allows you to work with large data sets and large models. And this can be quite tricky. Fortunately, we at Red Hat have collaborated with IBM on an open source project called Codeflare, which solves exactly this. There's also one question that I usually get, and that is if we should build or deploy our own models or use a model as a service API. And I think the answer is pretty straightforward. And it all comes down to privacy and security concerns. So if you have sensitive data, you cannot use a model as a service third-party API because you cannot share that sensitive data with them. It's as simple as that. So AI-enabled applications. This is where you want to end up. This is where you will start to see a return on investment of your AI efforts. And I think a really cool solution here is the code assistants we've seen over the last year. So developers can finally have a code assistant that will help them become much more productive and efficient in their daily work. So this is just one example, but of course you want to be able to build the applications yourself, and having both app development and AI development on the same platform, you can build AI-enabled applications that scales across the enterprise. And just as a reminder to emphasize that this is where you want to end up, at AI-enabled applications, because this is where you will start to see a return on investment of your AI efforts. So with an open source approach, you will get the desperately needed transparency, you will have access to the latest innovation, and it will save you money. So it will allow you to build up your AI capabilities piece by piece in your own pace, and therefore simplify your AI adoption. And this is exactly what we offer you here at Red Hat. Here I want to show you a clear overview of how our product offerings are following the exact recipe that I've been talking through today. First, we have OpenShift, which I mentioned. It's an enterprise-grade Kubernetes platform that supports the hybrid cloud. Then for an AI platform, we have OpenShift AI. It's a composable hybrid MLOps platform based on open source. And it's tightly integrated with OpenShift, which you can hear from its name, OpenShift AI. So being based on open source, its upstream project is called Open Data Hub, and it's been around for many years, and it's used globally by organizations in production. So we've been doing this for a long time. For models, we want to make sure that you have full flexibility. So we recently announced RHEL AI, which is a seamless way for you to develop and run large language models for enterprise applications. Then we want to make sure that you can bring your own models. We want to make sure that you can even train your own foundation models from scratch. And this is exactly what IBM did, where they trained a foundation model using OpenShift AI, and they used more than 4,000 GPUs. So the platform has been stress tested, to say the least. And we also want to make sure that you can use any open source model, really. And you can also get help with model support from our partners like IBM Watson X, Stability AI, and NVIDIA, which also provides models out of the box for specific use cases. And then for AI-enabled application, I want to highlight something we provide, which is called Red Hat Lightspeed. And there we have Ansible Lightspeed, OpenShift Lightspeed, and RHEL Lightspeed. And if we take Ansible Lightspeed as an example, it's a code assistant. So Ansible developers get this as an integration to their IDE, and they get help with writing Ansible scripts. And the foundation model for this project or this product is the one I just mentioned that IBM trained using OpenShift AI. So you can build your own AI-enabled application that scales across the enterprise with this stack. We proved it because we've done it ourselves. So at Red Hat, we can not only help you simplify your AI adoption process, we can also help you accelerate AI across the hybrid cloud, which is where the workloads are and will be. Thank you. And now I want to hand it over to Belka.
So thank you, Martin. Hello, and thanks for joining that session. As we have seen from the previous presentation, the AI era is upon us. But, and this is a big but, the recipe of success to unlock the full potential of AI up to the edge and everything in between is to adopt a mission-critical automation approach like we're gonna see throughout this presentation. I'm Belkacem Musuni, and I'm in charge of running the automation business development in Europe, Middle East, and Africa at Red Hat. We're gonna cover 3 points. First, we will explore how automation becomes your company innovation engine as the AI foundation. Secondly, we will see why embracing a mission-critical automation mindset is not a nice but a must to have. And finally, how Red Hat can help you scale automation at the level of your ambition as part of your digital transformation journey. In brief, why change? Why now? Why with the Ansible Automation Platform by Red Hat, which is simply the automation that does more, particularly in the AI context. So let's get started by acknowledging that change is one of the few constants in this ever-evolving nature of this industry with DevOps, GitOps, IOps, whatever ops. And we think that IOps are on the precipice of the fundamental shift that will change how customers think about the IT teams, the operation, and also the role of automation. Why is that? Because in order for organizations to truly participate in the AI revolution, they will have to have a strong automated IDOps foundation in place. And at Red Hat, we have two clear positioning towards AI when it comes to our automation strategy. First, has an enabler to provide the needed environment to run and scale your AI workloads from the day 0 and day 1 to the day 2 operation. And secondly, has a consumer of AI to generate faster the quality automation content that you need. And as you have seen from the Martin presentation, our AI strategy is built on several levels with Red Hat Enterprise AI and OpenShift AI. And the last one in this strategy is where automation comes more into the play by allocating and delivering the right infrastructure resources to workloads with specific requirements like AI. And where there's simply no AI without automation, here are 3 key aspects. First, why automation is needed for AI is because of adoption, to increase it. Automated environment enable the adoption of AI models across multiple environment and platform consistently and reliably. This ensures that AI solutions can be scaled to meet the needs of large and extensive usage with the right prerequisite and adapt automatically if needed. The second reason, it's around resources optimization. It's about to free up human time to let them do what they do best by also automating routine and repetitive tasks around the infrastructure, networking, storage, and so on and so forth, and the deployment also of the AI workloads where people can be allocated to more strategic and creative tasks. And this leads to more innovative and effective AI solutions as well as cost efficiency aspect. And last but not least, it's about control. Automated processes enforce governance and standardization across AI operation in the way you can access data and model deployment. And this consistency makes it easy also to secure access on who can do what, when, and where, and therefore simplify audit as well. And this reminds me another advertisement from a tire manufacturer, Pirelli, saying that power is nothing without control. And if you understood here the analogy, power is AI and control is automation. And those reasons that are not an exhaustive list highlight how automation not only facilitates the initial adoption of AI, but also ensures its control expansion across an organization. So to highlight this importance of such automation approach, you can see that the market here and other analysts are unanimous to address the points mentioned previously, with the need, to not say the necessity, to have such mindset shift around automation happening in the market. Automation clearly become mission critical for organizations, looking to operate as efficiently as possible and looking also to be as ready as possible for the AI transformation. This is the movement being taken by many organizations, considering that a unified automation has a critical role in the business and transformation strategy, such as AI adoption. And it's also, for some of you that joined today, a great career opportunity, as many organizations are looking for more automation architects to better embrace this movement. So where does that leave us? Simply by saying that automation is the foundation of AI to get the most out of it. That we can represent what we have talked about so far in those 3 simple steps process. First, by standardizing it to gain consistency around a common code base for use across the organization. Secondly, codify. This is where the organization how-to knowledge is hardened and preserved, taking out all the heads of subject matter expert and turn it into trusted, manageable, and shareable code. And last but not least, operationalize. This is where disparate tools and processes are integrated in truly end-to-end automation systems. Now that we have seen the interconnection between AI and automation, let's explore now why and how to embrace a mission-critical automation approach is much needed. Because the complexity is killing us. So here's the question that ties back to organization challenges we see often, to not say always. They say that if I got the skills and resources shortage, budget constraint, and not enough time in the day, how the hell I'm supposed to operate consistently across everything I have to get done on infrastructure, networking, edge, and so on and so forth, and at the same time, adopt AI. One of the common problems that limit the organization to automate at scale or to adopt a mission-critical approach is standardization. That's one of the biggest challenges when we discuss with customers. We see teams belonging to the same organization but working in silo. Over the years, they have created a kingdom of isolation. Each teams have different solutions, different maturity level, along with different strategy and different tools. All that is difficult to integrate. And if you are like most of the organization, you are probably using automation already, but in pockets. And this ends up to be extremely difficult and inefficient in many points of view. When this happens, you cannot really scale and be agile. And it can take ages, for example, between the time you requested the solution and the time when it will be ready to be consumed. No later than last week, I discussed with customer. We're in 2024. This customer told me, hey, you know what, Belkacem? I need sometimes 2 to 3 weeks just to deliver a virtual machine ready to be used. So here the solution is to come up with a unified automation platform to act like an abstraction layer, which will help not to break down the silos. Let's be honest, silos have always existed and will somehow continue to exist, but it will help to bridge the silos, to increase collaboration, which means also not replacing all the tools, because one size doesn't fit all, but one automation platform that can rule them all can apply. And here, this platform, when it makes sense, can complete some of the missing features and capabilities where needed on the tools you're already using in order to reduce technical debt, among other benefits, but also enable better AI adoption by deploying and managing automatically the needed environment to run the AI workload. And at Red Hat, we have the right platform helping you to embrace the mission critical automation approach. And this platform is called the Red Hat Ansible Automation Platform, which is a comprehensive and unified solution for strategic automation. It combines the security, features, integration, and flexibility needed to scale automation across different domains that you can see here, such as security, edge, networking, infrastructure, and so on and so forth, but also orchestrate essential workflow and optimize IT operation to successfully adopt enterprise AI. So it's designed to help any organization to tackle a huge range of operational challenges. And it's built on a strong open source foundation, which is called the Ansible project. And the Ansible Automation Platform is engineered to help organizations to create, to manage, and to scale the automation they need anywhere they choose to run it. And this is a more detailed view of the Ansible Automation Platform modularity around those three pillars that I just mentioned: create, manage, and scale. And these are tools and capabilities that the Ansible Automation Platform brings together into what is much more a unified experience for the developers, operators, and consumers of automation within your organization. And this will help you first to deliver consistent and reliable automation across domain and use cases. Secondly, to maximize the value of the technology and resources you already have. And third, to build a strong foundation for AI adoption. So on the following slides, we're going to focus now more on the few components that you see here, which are a key aspect of our strategy to adopt a mission-critical automation approach. We're going to focus on the component around the Ansible Lightspeed, around the event-driven Ansible controller, and also on one of the upcoming capabilities of the Ansible Automation Platform, which is the policy as code, not represented in that slide because it's not generally available yet. So at Red Hat, we believe that the key to getting the most out of the automation is to drive it from an enterprise level. That involves multiple teams working together to create automation as code. But let's be honest, getting the most out of the automation require a kind of, multidisciplinary skills across a set of technology, because we know that workflows can be complicated and time consuming, and that also writing quality automation code takes time and resources. And that's where the Ansible Lightspeed comes into the play with Watson Code Assistant from IBM, which is a generative AI services to help automation engineers and developers to create, manage, and deploy Ansible content, and meet automation engineer and also developer where they are in their expertise and help them rapidly advance their skills. And the model has been trained specifically on Ansible dataset. So it's more trusted, more accurate, and more also relevant than other commercially available large language models. It also includes model customization and fine-tuning, so you can use your own Ansible content to train the model and receive tailored responses based on your unique organization needs. So it's important to note here that also, because that's something that come often when we talk about this service, that all data in transit are encrypted and ephemeral. So you potentially can be confident to trust the service during the exchange. And in terms of data security, customer Ansible playbook are not shared with IBM, Red Hat, or any other third parties. So this will allow to lower the barrier to entry, enabling more efficiency by reducing, for example, development efforts, and by scaling also the audience within your organization who can access, create, and consume trusted and quality automation content. It will help you at the same time to address one of the challenges probably that all of you here face, which is addressing the skills gaps and accelerate the adoption of technology. If we take two examples here of persona, you have what we can call the automation novice. It will help them, leveraging the Ansible Lightspeed, to reduce the Ansible and YAML learning curve. It will help them to ensure that the automation content created follows best practices. It will help them to increase skills development and confidence. And for the subject matter expert, it's about bridging the gap between the automation ideas and automation content creation. It will also use the data model trained across automation domain, extended expertise. Also, we have, by the way, announced during the last Red Hat Summit, for those of you who didn't see that, the expansion of Lightspeed to the rest of our portfolio platform, meaning OpenShift and RHEL, bringing more consistency also on that domain as part of our open hybrid cloud strategy. And we have just scratched the surface on what we can do with AI, and we have an exciting roadmap around it. However, beside that, all the benefit that AI will bring, AI cannot be applied to manual and or broken processes, particularly with the explosion of volume of task and data to handle. The other important aspect here of our automation strategy is about bringing more reliability with an autonomous automation by bringing the EDA capabilities. EDA stands here for event-driven Ansible, as you can see, which is particularly needed in a day two operation, which is still far too complex and manual for too many organizations. And the concept of EDA, it's about bringing the synergy of three key blocks: observe, correlate, and act. Regarding the first step, it's about to conquer all the noise coming from all the various systems you have in your IT environment. And by the way, on that domain, we have many integration with observability solutions vendors such as Dynatrace, Turbonomic, Instana, and so on and so forth. When we pass the first step, we go to the second step, which is to correlate, to apply a conditional logic, right, based on the rule you will have predefined. And then the third step is to perform something that the Ansible Automation Platform has been always doing since its inception, which is to act, to automatically mitigate and remediate the task based on the event that has been generated. And this will help you to reduce human intervention with these more efficient end-to-end automated processes, therefore mitigate risk, therefore reduce cost, therefore reduce time from the mean time to detection and the mean time to resolution. In brief, it will help you to move on what we can call ClickOps approach, where you have to do many things manually when you receive those events and tickets, whatever if it's a change request or critical incident, to a full IOPS. And that's a concrete example on how to adopt a mission-critical automation approach. The other complementarity component that will be needed in the AI adoption is the policy as code. We are extending the Ansible Automation Platform directly into the realms of governance, risk, and compliance, so GRC to use the acronym here, with the policy as code capabilities that are going to be available to the next release of the platform. And the benefit of the policy as code has been bubbling away in several forms for some time now. We started out with the idea that has been backed up by customer conversation around some form of automation gatekeeper. And this was originally coming from a few organizations in the financial industry where the need of gatekeeper was due to an incident last year. And among many other incidents, I'm pretty sure, where an intern within one of those, and I will not name it, this financial institution, one intern brought down thousands of servers during a patching utilizing an automation tool that lacked governance control. And this incident, as you can imagine, had a significant impact on this financial institution and the ability to complete transaction during some times. So that's why it's extremely important to have guardrails, particularly when leveraging the power of AI. And that's why here we present in three categories the policy as code kind of stages. First, it's around governance, to check the policy enforcement during the development cycle. Secondly, it's around risk, by providing an integrated mechanism for policy enforcement based on unique needs. And last but not least, it's compliance, reporting mechanism in order to aid compliance status and audit tracking. So beside the key capabilities of the platform we just talked about, another extremely important element of mission criticality here is the fuel of the platform, the automation content, with the ability to deliver consistent performance across various domains to be automated, thanks to more than 150 certified and pre-built content collection available to build from, such as ServiceNow, Cisco, Palo Alto, Splunk. I mean, you see many of them, or some of them in that slide. Of course, also certified content for the full Red Hat portfolio platform with OpenShift and RHEL. We are here simply talking about the biggest ecosystem of certified vendor in the world for an IT automation platform. So what does it mean for you? For people, for example, who need to have the right infrastructure environment to use or train the AI model or workload, it means a higher guarantee to have it in a fast and secure way. For this time, the people who would like to reduce the development efforts to generate quality automation content through the usage of Ansible Lightspeed, it's a guarantee for you to accelerate the expansion of a search ecosystem with more partnership that can be forged every day. So, bottom line here, customer can be confident that Ansible platform is the right choice to get the most out of the automation strategy. And the Ansible automation platform is engineered to connect with something else. So that's the value of the Ansible automation platform also, is the power of end something and enhance some of the tools you are already relying on. So we could have even named the Ansible platform the Ansible integration platform if you wanted. And automating at this level is also about trust. So that's why we have introduced the end-to-end secure supply chain. So we have discussed about the certified content collection, but it's not it. We have also introduced the validated content, so an opinionated approach with playbook ready to use, developed and tested by Red Hat to avoid you reinventing the wheel for, let's say, basic use cases across different domains you want to automate. And the third step on the secure supply chain is to give you the ability to sign your content. And all that will give you a kind of peace of mind on automation happening across your organization in order to better focus on your core businesses. And there's a myriad of use cases that Ansible can cover. You can see some of them illustrated here. To give you an example, the synergy between the Ansible platform and the OpenShift platform. And yes, the Red Hat platform are better together. In that case, is how to improve or to better automate the infrastructure coordination for OpenShift, how to automate the last mile configuration of OpenShift, how to ensure the business continuity by automating the disaster recovery when you have multiple OpenShift cluster, and so on and so forth. So if we summarize what we have seen so far in that second part of the presentation, the Ansible automation platform will help organizations to embrace not only the infrastructure as code that exists for quite some time already, but also helping you to call that the day two with the operation as code, such as leveraging the capabilities around EDA, as well as the policy as code we just talked about. And also help you to go beyond by embracing modern practices such as platform engineering, which is the evolution of DevOps. So it will help to complete this cultural transformation to ensure that automated processes are created and executed in a consistent and scalable way. And the end result of that? It's a standardized, codified, and compliant operational foundation to bring AI capabilities onto. And this is a public references, Water Corporation, a state-owned entity in Australia that provides water to homes and businesses. In that case, it's using the platform, the Ansible Automation Platform, for both enabling AI workloads, but also consuming AI to generate automation content. They estimate here that the new automation strategy saves the business about 1,500 hours of annual manual labors annually associated with infrastructure support. And at the same time, the WhatsApp code assistance technology accelerated also the creation via Lightspeed of Ansible playbook and cut development effort by 30%. And all those savings help also the business offset the cost of running its SAP cloud environment by more than 40%. And we are just at the beginning of the AI capabilities on that domain. And finally, to move to the third and last part of the presentation, how to further drive adoption of automation, which will help to unleash the AI power. The world is embracing automation and AI like never before because it's a force multiplier for people. But you cannot automate cultural change. So in that case, automation is not an all or nothing proposition. You have first to prioritize what to automate based on the business impact. And at Red Hat, we will meet you where you are in this automation journey. Automation also should not be an afterthought anymore, particularly nowadays. And we will help you move toward the strategic level at the top right of that automation maturity curve to reach the optimized level on automating the automation, if you will. And it can be, for example, by helping you to put in place a community of practice, or start small with some of you by identifying, let's say, some specific processes to automate more efficiently. And that approach will become the foundation for successful AI adoption. But as part of this journey, you will face obstacles, obviously. And one of them is the human resistance of change. I mean, many people don't want really to change, but they would like to benefit of the positive outcomes of change. So, of course, there are some best practices to address some of those obstacles along the way. And I can give you like 3 examples. First, think like a software developer working in sprint with small releases cycle. In other words, don't try to boil the ocean from the beginning and rather have a kind of snowball effect approach. Find first the pocket of ad hoc automation in your company and grow them into a kind of formal automation program. Secondly, have an IT automation first IT mindset with a programmatic approach from top down to infuse the cultural change, and meet the bottom up approach from the automation practitioner. So that's it will help also at the same time to cover the misalignment, which is the gap between the, I would say, the leadership vision and sometimes the people who are supposed to execute the automation strategy. And last but not least, think big, think holistically, and start small. Of course, depending on your priority, your industry, and the type of your organization, this is just one example that probably will not apply to everybody, but if you can, start with the most boring, repetitive, and simple task. Avoid business critical processes when first starting, because the topic might be too broad to tackle as a big bang from day one. Because yes, I agree, in one hand, it can produce a significant benefit, but you might also meet more obstacles if you are not backed first by previous success with some quick wins. Meaning, demonstrate first the value of automation by showing how you can automate across multiple teams with a more simple use case, and then embrace more complex ones later. And a common point for most of our advanced automation customers who have reached a certain level of organizational effectiveness, so the level 4, level 5 that you have seen in the previous slide, It's by working closely with the Red Hat consulting services and or our certified delivery partner. We have consolidated, let's say, best practices gained from more than 3,000 organizations today around the globe from different size and different industry that rely on the Ansible Automation Platform. So we have structured, formalized those best practices and methodology in a program called AAG, which stands for Automation Adoption Journey, which is a tailored program-based series of increments to help you define and or improve your automation adoption roadmap. The goal here is to transfer, to infuse Red Hat practices in your organization to help you automate as one, to really automate in concert across your organization. And the key message here that you should remember, it's when you are working with Red Hat, meaning when you are using the Ansible subscription in that case, you are not just accessing to the platform or to the technology, you are also accessing to the brain, to the know-how, to the knowledge, or by accessing to the global consulting department of Red Hat and our ecosystem of certified delivery partner. So as we are reaching the end of the presentation, let's recap. As we have seen, the Ansible Automation Platform is a unified solution for automating the enterprise that is accessible to multiple teams and gives them the capabilities to tackle a variety of automation use cases across IT domains, while also maintaining consistency, reliability, and compliance at scale. Secondly, it's a force multiplier for IT ops that helps organizations get more out of the existing tools. For example, using EDA to make the observability tools more actionable or ITSM tools more compliant. And last but not least, it's the foundation for AI adoption. AI cannot and will not fix broken IT ops in the vacuum. And it's not a standalone solution for technical debt. And the Ansible Automation Platform here offers a streamlined solution for an automation as code approach that can serve as a trusted and compliant foundation for AI adoption. And before closing, here are some next steps. If you are an Ansible Automation Platform customers, you can get more information from your customer portal where we have added and updated information around automation and AI. If it's not already done, visit the IBM website to either try or buy, if you're already convinced, the Watson Code Assistant solution that has been specifically designed to work with the Ansible Automation Platform. If you are not a customer using the Ansible Automation Platform yet, get started by accessing to documentation guide, ask your trial to test the platform, watch recorded demo, and we have many other things available for you if you want to become the automation rock star within your organization. But most importantly, reach out to your local Red Hat representative and they will guide you in the right learning path for you. With that, I would like to thank you very much for your attention and looking forward to help you harness the power of AI with automation. And I will leave you now with Hin from Intel. Thank you again.
Thank you, Belke, for the interesting presentation that you gave. And welcome to this talk about bringing AI everywhere and how to unlock the full potential of AI. My name is Hind Azigruz. I work as AI Inference Lead for EMEA at Intel organization. So as we all know, AI is evolving rapidly, but Intel has you covered. AI is not new. It went from being an AI in the back room using high compute to a more modern data and AI architecture like data lakes and data fabrics that's enabling AI everywhere. Worldwide spend in AI is growing rapidly. A recent McKinsey study shows that AI spend is expected to exceed $300 billion by 2026, and 58% of CEOs of public companies are investing in AI, including, of course, Intel. By 2026, at least 50% of edge computing deployments will involve machine learning compared to only 5% in 2022. And when it comes to AI, you must talk about portability, and the AI PC, Gartner predicts more than 50% of enterprise managed data will be created and processed outside the data center or the cloud by 2025. But perhaps the speed with which generative AI has disrupted data science is unprecedented to date. The proliferation of large language models, well, large and small, to developing new applications means huge model sizes, but also the growth of enterprise class generative AI models. With the large user base of generative AI, a surprising result is AI inference is driving the cost of compute, not pre training. So let's have a closer view on the AI pipeline to understand how to efficiently run your AI project. So basically, the data is ingested from single or various sources, formatted and cleaned, and made ready for model development. Then it goes through an iterative training process to find the best model to then later optimize and deploy. Let's start from the left of the pipeline and see how hardware fits in this pipeline. Today, about 80% of time for the AI solution is spent for data pre-processing. This is a very iterative process requiring large memory, data storage, data transforms, and it has mostly been done on a CPU. The software ecosystem here for a CPU is extremely robust, mature, and yet growing at an amazing pace. Let's look at the extreme end on the right. Xeons have always had a great performance on most of the inference workloads, and CPUs are widely used for inference purposes as they provide excellent efficiency. In the middle here, the training part, I would split this into two: machine learning and deep learning. Training classical or traditional machine learning here has a similar story as the data preparation. It mostly has happened on CPU, and Xeon offers amazing performance for classical machine learning. Once again, very rich and popular industry, favorite frameworks and libraries with millions of monthly downloads are optimized and hence show great performance and efficiency on a Xeon CPU. Deep learning training is that piece where vectorization and parallelization hardware capacity helps immensely, and GPUs and AI accelerators such as Intel's take a leap in improving the deep learning training performance. So, for most of the AI pipeline, you can utilize the Intel Xeon CPU, which is an ubiquitous and well supported cost effective alternative to GPU environments. With broad ecosystem software support for Intel Xeon processors, Intel Habana deep learning processors, and Intel GPUs, data scientists can select an architecture well suited for a particular AI solution and reuse their code without rewriting for another architecture and platform like CUDA. Let me show you some examples on how to tailor your hardware platforms to your workloads. So, at the foundation of the technology stack is the range of standard based Intel architecture platforms, including both conventional hardware and IaaS from leading cloud service providers. These infrastructure options enable interoperation by customer workloads among CPUs, GPUs, and accelerators for optimized results across key performance indicators or KPIs such as time and cost to train, as well as inference throughput and latency for varied usages and requirements. In contrast with proprietary solutions that inflexibly tie customers to a specific hardware architecture, Intel Enterprise AI is explicitly a platform neutral, which enables different hardware capabilities to be deployed at different stages of the pipeline or even within a single stage. For the particular case of large language models, we can see that depending on the use case, on the size of the models, and the task in hand, there are several possibilities of usage of hardwares that can be recommended. So, for example, for training, if the training parameters are around 1 billion, and if we have to handle end-to-end data pipeline, then a Xeon server can do the job. If we are interested in training only, then a Gaudi server can handle up to 20 billion parameters models. And similarly for fine tuning, we can use a Xeon server as long as the model parameters are less than 10 billion parameter, and this can grow to 70 billion if we are using a Gaudi 2 server. For the case of the inference, we can even use the core processors to run up to 20 TOPS and run the inference of models that are as small as 20 billion parameters on Xeon workstation servers. This model inference can run for models that are as big as 350 billion parameters smoothly on Gaudi 2 servers. And of course, these parameters will grow as we grow the size of the clusters or the servers of the Gaudi that are involved. So we spoke a little bit about the hardware portfolio that Intel offers and what are the use cases that are suitable for each hardware. That one thing that is also important to mention is the Intel software optimizations that are available. Intel provides optimizations for popular AI ML tools and frameworks so you can get the most performance out of the Intel devices you run on with your existing code. This is enabled via OneAPI libraries, which are used by most of the popular tools and frameworks to detect and optimize for the specific device being run on. Intel also contributes higher level optimizations to open source tools and frameworks such as PyTorch, TensorFlow, Onyx Runtime, XGBoost, and scikit-learn. And to get the latest optimizations and features before they are upstream to open source, Intel offers its own versions that extend these tools and frameworks, typically with no or minimal code change. So if we take a little look at the engineering data tools, for example, Modin adds parallel processing to Pandas data frame processing using the same API. You just need to change a line of code and use all your available processors. Optimized versions of NumPy and SciPy and Numba ship in Intel distribution for Python, adding parallel processing for Intel CPU and GPU. Apache Spark OAP MLlib utilizes Wandal optimizations. Intel contributes to optimizations to open source AI ML frameworks such as PyTorch, TensorFlow, XGBoost, and scikit-learn. New features, as I said, and optimizations that are not yet available in open source frameworks are released first in Intel Extension for PyTorch, Intel Extension for TensorFlow, and Intel Extension for scikit-learn. On the other hand, SIGOPT automates hyperparameter tuning and experimentation with popular AI ML frameworks, and Intel Neural Compressor performs model optimization techniques such as quantization, pruning, and distillation using the same API across PyTorch, TensorFlow, and Onyx Runtime. Intel also collaborated with Microsoft to optimize DirectML for inference on Intel VPUs. And Intel offers the Intel distribution OpenVINO toolkit to speed up and improve the inference on all the different hardwares. And talking of OpenVINO, this is a great tool that allows you to start from a pre-trained model in any of the frameworks of choice, such as PyTorch, TensorFlow, Keras, TensorFlow Lite, Onyx, Caffe, or Paddle, and then pass it through OpenVINO that in itself will optimize the performance so that your latency is decreased hugely once you run your model, be it on CPU, GPU, NPU, or FPGA. Needless to say that OpenVINO supports all the major operating systems, Windows, Linux, and Mac. In a nutshell, Intel's enterprise AI is a one-click deployable AI development package for rapid time to development and production deployment over the top premium software, toolkits, and ecosystem partners. It reduces the setup time from weeks to minutes, and it unifies all Intel AI end-to-end tools and software into one package. It integrates with OEM and ISV partner infrastructure, and it allows for portability from workstation to server to cloud, allowing scalability across CPU, GPU, and AI accelerator. Let's take a real world example for tuning models for local languages. Red Hat and Intel teamed up to deliver a generative AI stack for AI Sweden. AI Sweden is Sweden's national center for applied AI. They focus on accelerating the use of AI for societal benefit with more than 120 partners across public and private sectors and academia. In addition to Xeon CPUs, we included the Gaudi 2 accelerator cards, which excels at natural language processing and model tuning. Coupled with Red Hat platforms, we aim to empower Sweden's AI experts with flexible and powerful solutions so they can deliver more models more quickly using open source technologies. This is one example to show the kind of deep collaboration that will be pervasive in AI. Your plan may have different ecosystem partners in the stack, and so our focus is having a broad and relevant ecosystem to do this level of collaboration to meet your needs across multiple hardware, technologies, multiple deployment venues, and with many models and application solutions. As we have now discussed the hardware to run your AI pipeline on and the software environment to manage your AI workloads, let me point you to another important topic, which is security. Securing high-value IP such as machine learning models. This includes memory encryption, integrity tracking, access control from privileged processes, and more. The CNCF, Confidential Containers (COCO) project, provides a platform for running confidential cloud-native solutions such as your AI models in your familiar OpenShift environment. Using COCO with Intel Trusted Domain Extension, TDX, for creating trusted domains for AI workloads, Intel TDX encrypts each virtual machine with a tenant-specific key and can be configured with just a few clicks during the virtual machine setup. With TDX, only the guest operating system and the container inside the virtual machine are inside the trust boundary. This is how you can reduce the risk of unauthorized entities accessing your workload data and extracting your secrets, knowing that neither the cloud service provider nor other workloads sharing the same infrastructure can access or manipulate it. So, in summary, what I would like to advise you or to invite you to is to take the next steps. The combination of Red Hat, OpenShift AI, and Intel Enterprise AI provides a unified, consistent environment for AI solutions where the burden of choosing and integrating together components is shifted away from the customer. Project teams choose the combinations of technologies appropriate to their requirements without vendor lock-in. Solutions built using this approach reduce risk, cost, time to market with enterprise security features and support as they progress from the lab and the testbed into production. Thank you very much. And now I will pass it over to Bruno, who will take us through a demo.
Hello, everyone, and welcome to this AI demo where we are going to see an evolving AI ML solution. So let's dive into it. So imagine yourself, you're walking the corridors of a superstore, and in your handset, you can actually take a snapshot of a particular article and then check the price or see what's the offer on that day. Another example would be once you have done all the shopping, you go to the conveyor belt for the checkout and you put all the articles in it, and you have a smart camera there that is scanning all the products, identifying them, and then calculating the final amount you have to pay. So how do we construct all of this? So let's go through 4 very important stages I want you to go through. First of all, let's look at all the bits and pieces here on the left. So these are all IoT devices and users interacting with the platform. And the very first thing they need to do when you want to, let's say, onboard a new product to the catalog in the superstore, then you enter into the data acquisition phase. So basically, you want the staff to push training data and store it locally. So this is happening at the near edge where the store is, and ingest as much data as you can for the training. And once you have a full collection of training data for a particular product or a collection of products, then you're ready to push that to the main data center where the training is going to happen. And then we enter into phase 2, which is called data preparation and modeling. And well, the first thing that needs to happen is there should be a team of data scientists that are going to design and implement all the processes that meet the requirements and produce, the implementation for generating models for the shop. And so, but when all of those are ready, then basically you can enter the third phase, app dev and delivery, where you just add some integration bits and some automation with OpenShift pipelines and GitOps. And basically, this is going to mechanize and automate the release of new versions of the model and new versions of the smart application, and so that they are ready to be pushed to the edge. And finally, on the fourth phase, then we have the live AI ML inferencing, where real traffic coming from users and shoppers are going to be firing traffic and then basically triggering inferencing to identify the information, to obtain price tags and pricing information and so on. Right, so let's jump to the demo and let's see how all of that is built. So we jump to our environment where you see that we are in a namespace called Edge 1. This represents to be the shop space, and basically here the most important deployment is this one, the shopper application. This is the one that implements the smart application that can be used by the staff and users, and that is going to be interacting with the model server that is going to be in charge to execute the inferencing and recognizing all the products. And once you have a product, then the shopper can integrate with the pricing engine that has a catalog with all the pricing information you can fetch and then respond with and then pass to the users. All right, so let's see how that executes. So let's have a look to what this smart application looks like. So switching windows, what I want to show to you is, it's thinking a little bit, right? So on the foreground, we have this window, which represents the smart application that you can open on your phone as well, but we are opening here in a tab. And on the background, we have a monitoring view that is going to run some animations that are going to illustrate how the different systems are interacting between each other. And so the first thing we want to do is actually enter in detection mode to show you how it works. So basically, it opens the front view camera. And imagine I have this product. So this is a tea bag that I have. So this is green tea. I could take a picture here and then just run an inference and run it. And instead of doing using this photograph, I'm going to just pick a file from my machine, which is the same tea bag, but I want to do this because I want to reuse the same image later on. And you'll understand why. So I'm going to send this via MQTT, which is a well-known protocol for IoT. And when I do so, you'll see that I'm going to fire an event. So let's go and click it. So when I do, you should see an event that is picked up by Camel, pushed to run an inference, but it's found invalid and then pushed to the unclassified data bucket. The reason for that is that this, TBAG, this product, is actually not known to the model that we have preloaded. So this version 1 model only understands about two different articles, two other types of T, but not this one. We haven't trained this particular article, this TBAG, this type of T, for the AI engine to actually recognize it, right? So let's just run a positive test case so that you see what I mean. If I open this other file, so for example, this T all gray, I open it, and then you'll see that the image loads there. I can just zoom in. You see that it's an Earl Grey tea box, yellow box that I had at home, and basically I took pictures and I trained the model that is right now deployed on the AI engine. Right. So when I fire this, let's see what happens now. An event goes by the broker and then is pushed to the AI engine. This time it finds it valid, and we have a $3.99 price tag for the product, and then that's pushed to the training data. All right, so we run, a negative test, a positive test, so that you see that there are current products in there, and there are others that are not. Right. So the next phase, basically, what we need to do is to really train the new product, and for that, let me just very quickly open Red Hat OpenShift AI. So this would be the environment where data scientists work. And here we have a project that is already pre-deployed as well. And we should see there an already running workbench that I can open. And this is going to open Jupyter Lab. So Jupyter Lab is where data scientists can work on the notebooks. So notebooks are these pieces of code where data scientists combine Python with AI libraries, in this case TensorFlow, and they can create all the functionality that it is required. They also produce a workflow to actually, mechanize and automate this. And you see that there are 3 steps here. And basically, they compose this by just simply dragging and dropping these activities in here. I'm not going to do it because it's done already. But basically, this first step, you see that it's about loading training data. So this is going to find a bucket, is going to download all the images, and then that would allow the second step to actually do the real training. This is the one that produces a model, and once a model is available, then the third one is going to push this to another S3 bucket so that then it can be fetched by the edge and then hot deployed in the edge environment in the shop. Right, so they are going to build these workflows, and from here, then we can click this button that says Export Pipeline. And what this action is going to do, it is going to take this graphical workflow and translate it into an OpenShift Tecton pipeline in a YAML definition, right? And with that YAML definition, then we can go to OpenShift and import it. And let me show you where we have done this. So if we click here, pipelines, and then I choose the namespace where the pipeline is included, you see that it is there in green. It is green because I did execute this earlier just to check that it was ready for the demo. But if I look a little bit more in detail, you see that it has the 3 steps that we've seen on the graphical view. So basically, this is the pipeline that we want to trigger once we are ready. All right, so let's go back to this view. So what now I'd like to show to you is the how we are going to train these, but for this we need training data, of course. And so this view here actually looks at the S3 bucket that will contain all the training data. And what you can see is that at the moment it is empty. We have no training data. So basically, we need to generate the training data in order to include a new product in the catalog. So let's do that. I want to show you how we do that. And basically, we go back to this view. And then what we do is we go back to the smart application, and it has another button that says enter in ingestion mode. And this is to generate training data. So I can click on that. And you see that it's already pre-configured to train this type of product. So the user just selects this type of product and clicks OK. Then it could take the product that needs to be trained. In this case, it will be the TBAG. And then we can take a picture. If I put it on the front of the camera, I take a picture. And then we could push it to the system to actually ingest this as a training data. But what I want to do instead is to use my smartphone. So I'm going to use the smart application so that you see how it is done. So let me just very quickly open it. You see that I have here the same application. I'm going to enter ingestion mode. I'm going to select the same training data, so green tea, which is Bali tea, and then all I'm going to do is, take a picture of it on my desk. And when I do so, I'm going to take a picture, and now I'm going to push it to the system. And you should see an event when I send it. Here I go. So I click send, and you see an event that is picked up by Camel and goes directly pushed to the training data. Right, so we have one image already available in the bucket, but of course we need tons of data. And well, unfortunately for this recording, we don't have a live audience that could join us or staff members. But then what we do is we simulate that there's staff and people that actually are going to generate that data. So I have a script for that I'm going to trigger now. I'm going to say sim audience. I launch it. And if we go back now, we see this very nice illustration and animation where we see plenty of events coming in, simulating they come from a device, because what a staff member would need to do is to take the product, take pictures from all angles, from the top, from the side, from the back of the product, and push it to the system to generate hundreds of images. The more images, the better. And so that the model, it is accurate enough. Of course, with a live audience, this would be a lot more fun, because you make them, you give them the application, they can play with it. You give them a nice product and a nice little tea bag or something. They can take pictures and they interact with the live system. Also, it's fun because you can tell them that make sure you don't take random pictures, otherwise, you are going to introduce inaccuracy in the model, and then that might break the demo. But okay, all in all, this is going to finish soon. We have around 100 images. This is actually a replay from images we gathered on a live session. And so just to show you that we have the pictures now in place, I'm going to refresh this view, and then we should get the pictures. And let's see. Oh, there they come. So the very first picture you see is the one I took with my phone on my desk. So that's the picture I pushed. And all the others are the ones that we have pushed with the script. And so, like I say, all these pictures are real. These were taken with a live audience, so it was a lot of fun. And all right, so now we have a good bunch of images. And what we can do is initiate the training. So I'm going to click here on this button, train data. And when I do so, then you will see on this animation how there's a Camel integration that is reading all the files from the S3 bucket and packing all of those into a zip file that then is going to be pushed over the wire via a secure connection with service interconnect that is picked up by another integration point on the main data center and pushed to a local S3 bucket. Then it kicks off the Tecton pipeline, and you see that the very first thing it does, it reads all the training data, and the real training starts happening. Right, so this is when that graphical workflow we saw earlier is in execution, and will take a little bit of time. And I want to show to you that this is actually happening for real in the system. So I'm going to go back, and you see here that we have the pipeline that actually has just completed the first stage, and now it is completing the second stage, which is the real training. And I'm going to superpose that with our view from earlier. And well, okay, so this is going to take a little bit of time. And while normally in other AI demos you might have seen, probably they already had version 2 ready, because of course this is the phase where training data is very CPU hungry. You need hundreds of images. It takes a lot of time, and generally you cannot show this, but we can today. So this is a real AI training that we are doing, and we can do this because we have shortened the time considerably, because we are using a technique that is called transfer learning. And with transfer learning, what we are doing is we are reusing a well-known AI model that there's out there for image recognition, and we are keeping most of the functionality to recognize, the features of an image, so edges and the brightness, colors, and so on. And the only thing so we are keeping most of it, and the only thing that we are doing is stripping the very last layers of the neural network. And then we are reconstructing the last layers with our training data, and we are adding that to the very end. And that's why we are shortening the training process quite substantially, because we don't need to train the whole model. And you see that now it is entering into the last phase. It has completed the training, and now it's going to push the new model. And we should see that on the animation there, how the new model is pushed to the buckets. And once it is in the bucket, it can be fetched by the edge, as you can see. And then it is hot deployed on the AI engine, which then now would be running on version 2. Version 2 is the one that now knows about this new product, the new T-bag we have trained. And so, okay, let's prove that. Let's just go back to our application here, and we enter again into detection mode, and I'm going to open the same file that we had earlier, just to the one that was failing, that was not able to recognize. So if I open this and now I send it, let's say, via HTTP, the result we get, let's have a look to that. The event then goes to the AI engine, and it finds it valid, and we find a price tag of $249, and that is placed on the training data. Now, the $249 is a configuration that was already prepared for the demo, so we haven't done it live, but it was already in place. The only thing that we needed to do is to train the new model version. Well, with that, we have seen how successful it was, the training, and now we have the product that it is recognized by the system. And just to recap a little bit, what we have seen is a bunch of technologies with Service Interconnect to connect both environments, integration with Apache Camel, automation with pipelines, and many other technologies that allow us to have this continuous circle to generate and ingest training data for a new product, produce a new model that can be released and pushed to the edge environment, and that is hot deployed without any service interruption. And of course, users can always do the live inferencing and obtaining all the data. Now, if you have liked this demo, you can find all about it and a lot of more information in this page, Solution Patterns Catalog, where it is included. You'll find many other patterns as well, but if you go to this website, solutionpatterns.io, then you'll find this one included there, and please explore all the other patterns as well. Thank you very much for listening, and hope to see you soon. Bye.